Let's say we want to predict a student test score based on how many hours they studied. Our model makes a guess, but how do we know if that guess is good or bad? We need a way to measure the mistake. That's where loss functions come in. A loss function gives us a number that tells us how far the prediction is from the actual result. Let's walk through a simple example from the previous video. A student studied for 5 hours, their actual score was 85, the model predicted 70. So the error is 85 minus 70 equals to 15. But we don't stop at just knowing the error. We want to turn this into a single number that the model can use to learn. That number is called the loss. One of the most common loss functions is mean squared error, especially for regression problems. Let's see how it works. First, square the error. So now it's 225. If you have multiple predictions, you average the squared errors. But in our case, we only have one prediction, so the loss is 225. The model will use this number to update itself. Why do we square the error? There are two main reasons. The first reason is that all errors become positive. So underpredictions and overpredictions don't cancel each other out. And the second reason is that the big mistakes get punished more. Squaring amplifies large errors more than the small ones. This helps the model focus more on fixing the biggest problems. Now let's imagine plotting the loss. On the x-axis, we'll put different model weights. On the y-axis, we'll plot the loss for each weight. You will see a smooth ball-shaped curve. This is the loss function. At the bottom of the ball is the minimum loss, the best weight the model can find. The goal of the model is to minimize the loss. It starts with random weights and checks the loss. Then using an optimization algorithm like gradient descent, it takes steps downhill toward lower loss. Step by step, the model updates its weights. Eventually, it reaches the global minimum, where the loss is the smallest. At that point, the model's predictions are as close as possible to the actual data. There is no one-size-fits-all loss function. Different problems need different tools. For regression, we often use mean squared error. For classification, we use cross-entropy loss. For robust regression or when detecting outliers, we might use mean absolute error. For imbalanced datasets, special loss functions like focal loss can help. Each of these functions has different properties, but they all do one thing: tell the model how wrong its predictions are. To summarize, a loss function measures how wrong a model's prediction is. A cost function is the average loss across all training examples. The loss curve shows how a loss changes with different weights. The model learns by adjusting weights to minimize the loss. Loss functions are the compass that guide the learning process. Without them, machine learning would be blind. Simple, powerful, essential.